Good afternoon. Today we're going to cover 4 different types of story problems that are based on a linear model. And I'm going to try to categorize them so that when you're approaching an unknown problem, you have some basic patterns in mind. Okay, so here's the first one. This is your basic mixture problem. You can always spot a basic mixture problem because you're going to have two items that are mixed together and you're trying to separate them out and find out how much there are of them individually. So an example of this is a muffin question. 3 coffees and 2 muffins cost a total of $7. Notice that coffees and muffins are mixed and you're given a total. 2 coffees and 4 muffins. So different amounts. 2 coffees and 4 muffins cost $8. What is the individual price for a single coffee and a single muffin? So first thing you want to do is determine what you're trying to find. We're going to say that M is the cost of 1 muffin, of course in dollars. And then I'm going to use C for the cost of 1 coffee in dollars. Okay. And so we're going to make 2 equations based off of what they've told us. Totals are something you always want to look for. They've given us a total of $7 with one situation and a total of $8 with the other. So if I were to figure out where that $7 came from, there were 3 coffees. So 3 times C, which is the cost of 1 coffee. There were 2 muffins, so 2 times M, which is the cost of 1 muffin, that added up to $7. In the second situation, the 2 added up to $8, but this time there were 2 coffees, so 2 times the cost of a coffee, and 4 muffins, so plus 4 times the cost of a muffin. Again, keywords like total, you want to look for. Sometimes they'll just tell you like what the total number of items were. Oftentimes you have what I call a counting equation where you're just adding number plus number equals total. This particular one had 2 different totals that make the equation. Okay, so once you have your 2 equations, you can use substitution method or linear combination. For these kinds of problems, I actually find that linear combination is typically the better one of the 2 to try because there's no lonely only to solve for. So if I was going to solve this using linear combination, I would probably eliminate the m's first. So I would take the first equation and I would multiply it. To make these go up to 0, I need this to be a negative 4m, so I'd multiply everything by negative 2. So that would be negative 6c minus 4m equals negative 14. I would probably just use this one as is. So 2c plus 4m equals 8. Add it up. The muffins cancel out. Negative 6 plus 2 is negative 4c equals negative 14 plus 8, which is, I think it's negative 6, 8, yeah. So I'm going to put dot, dot, dot because this example, it'll still work. There's going to be dollars and cents. So you would keep going and find the cost of a coffee, and it wouldn't necessarily be a whole dollar amount. Anyway, that's how I would start it. Okay, so that's your first type of problem is a mixture problem. The second one is a linear function from pairs of data. So we're going to write from pairs of data. Okay, so here's an example. Out of 5 people in this class, what percent own a dog? And out of 16 people in this class, what percent own a dog? What is the number of dogs if you have 30 people? Okay, so this is supposed to be one of these questions where you ask the class to give you the data. So instead of doing that, I'm just going to give you numbers. So out of 5 people, What percent owned a dog? Well, 3% owned a dog. And then if we surveyed 16 people, what percent own a dog? Ended up being like 11% owned a dog. And we want to know if there are 30 people, what is the percentage that would own a dog? The key of this one is to recognize that you have two pairs of data that go together. And so from that, you can make a linear equation that you can use to calculate for 30 people. So first thing you want to do is change your pairs of data into points. We're going to do 5, 3 and 16, 11. And we're going to write this in slope-intercept form, y equals mx plus b. So we need the slope. Okay, so remember your slope. Slope is y2 minus y1 over x sub 2 minus x1. Designate your points, x1, y1, x2, y2. Substitute them in the slope formula. So 11 minus 3 over 16 minus 5. So 11 minus 3 is 8. 16 minus 5 is 11. That is our slope. Now we need our y-intercept, so we're going to pick one pair of data to be our temporary x and y. I'm going to choose the smaller numbers because I'm lazy. We're going to put them into this equation. So our temporary y value is 3 equals my slope, which is 8 over 11, times my temporary x, which is 5, plus b. And we're going to solve. So 3 equals 40 over 11 plus b. Subtract 40 over 11. Let's see, we need to multiply the 3 times 11 over 11. So 33 minus 40 is negative 7. Negative 7/11 is my b value. Now that we've got that, we're ready to actually write the equation. Y equals slope 8 over 11x minus 7 over 11. That is our equation. Once you have an equation, now you can use your equation to calculate any number of percentages based on the number of people. So we're going to say if x is 30 people, so y equals 8 over 11 times 30 minus 7 over 11. 8 times 30 is 240 minus 7 over 11, which is 233 over 11. And when you run that through a calculator, it's 21.1818. So you're going to round. 1 rounds 21 to stay 21. It would be 21 dogs. So if all you've got is two pairs of data, turn them into points, find the equation of the line, and then use your equation to calculate what you want. So that is problem type number 2. Write your equation from pairs of data. Okay, equation type number 3. And this is these are these little tricky ones. These are what we call consecutive integer problems. Consecutive integer problems. And you can tell them because they have the word consecutive in them, and they're describing a set of numbers without any particular context. So here's an example. The sum of 4 consecutive integers is 282. Okay, what are the numbers? So we know that the sum of 4 consecutive numbers equals 282. Well, let's just pick letters for those. X is the first number plus Y plus Z plus W equals 282. Now, right now, this is not solvable because we have 4 different types of variables. What we need is to express each variable in terms of one of them. Typically, we express each of these in terms of X and make replacements. Now, the word consecutive means next to. So it's the next number up, and it's always the next number up. So if x is my beginning number, the next number up, the consecutive number, would be x plus 1. The next one after that would be x plus 2, because you start here and add 2. The next one after that would be x plus 3, and those add up to 282. This is now a solvable equation. I'm not going to go through the solving process. It's a pretty straightforward one. What if they tell you, though, that they want the sum of even consecutive integers? Even consecutive integers. So you still have x plus y plus z plus w equals 282, but these don't go by ones. Okay, well, this means that you have 2's in between, because that's how consecutive integers work: 2, 4, 6, 8, 10, 12, and so on. So your equation, you're going to do your starting x, and then for y, you're going to go x plus 2. For z, it's 1, 2, 3, 4, x plus 4. For w, it's 2, 4, 6, x plus 6 equals 282. Now, I'm going to warn you, sometimes when you build these equations, your answer turns out to be an odd number. That just is a byproduct of solving. So if that happens, you need to test plus 1 to the next even number, and then try it out with consecutives. And then if that doesn't work, test 1 down to the even number smaller than what you got. So sometimes it will be close but not right on the money, and you'll have to figure out which one will actually satisfy the original equation. All right, problem type number 4, last one. Past, present, and future age questions. Obviously, you spot it because you're talking about past, present, and future ages. Here's an example of a past, present, and future age question. Ross is 20 years older than his niece, Julie. Julie has worked out that in 5 years' time, her uncle will be twice as old as she will be. Find Julie's current age. So one of the best ways to do these is to set up a past, present, future chart. And to put the information on the chart. So we're going to say that Ross, his current age is R. That's his present age. So that's Ross's age. And we're going to use J for Julie's present age. Right now, Ross is 20 years older than his niece. Okay, so now we're looking for relationships. But before we do that, let's get the rest of the stuff on the chart. In 5 years' time, so in the future, plus 5 years, Ross will be R plus 5 years, current age plus 5. Julie will be J plus 5. These give us expressions to use in our equations that represent their future ages. So there's no mention of the past in this particular problem, so we can just leave that part blank. All right, so now we're going to do relationships, the relationships between the ages, and these will be our equations. So right now, so this is our current one, right now Ross is 20 years older than his niece. So if I take Ross's age plus 20 years, that's going to be Julie's age. That's now. In the future, which is 5 years in the future, her uncle will be twice as old as she will be. So in 5 years, Ross's age will be R plus 5, and that is twice as old as she will be, so twice Julie's future age, J plus 5. So Ross's future age is equal to 2 times Julie's future age. And those are your two equations. This particular one, you might consider using substitution method. since you have a nice lonely only there. But of course, you can use substitution method or linear combination. You get to choose. All right, all the problems you're going to get on the assignment are one of these 4 types. Identify the type and attack it using that problem type. Have a good afternoon.